And this is a very large chapter. Different subtopics are there. So first subtopic is temperature and its effect. Next we'll talk about calorimetry. Next we'll talk about heat transfer, and then kinetic theory of gases, and last we'll talk about thermodynamics, right? So all these subtopics are included in this heat and thermodynamics chapter. Okay, so
I mean, in NCERT, means it covers 3 chapters.
in NCERT, I don't know, in different books there are different chapters, but thermal physics you can say, or heat and thermodynamics.
Thermal properties of matter, that one.
Not thermal properties of matter. It may be heat, or I'm not sure, that I don't remember that what is there in NCERT.
Specific heat, all those things. So
Yes, everything is there in this chapter only. Right, so first let us start with temperature and its effect. We know that heat is one type of energy and temperature is the manifestation of that energy, right? By temperature we can understand which body is hot and which body is cold. And temperature also determines that from which body to which one the heat energy will flow, right? So if the body is heat will always flow from higher temperature zone to lower temperature zone. Now in order to measure the temperature, there are different scales formed. So three different major scales are there: Celsius, Fahrenheit and Kelvin scale, right? So how do we actually make these temperature scales? On all these temperature scales actually follow a very basic rule, that they will measure the freezing point and boiling point of water, right? All the temperature scales will measure the freezing point and boiling point of water, and in between them they will equally graduate their scale. So for example, if I talk about the Celsius scale, this is the freezing point of water, this is the boiling point of water, and these points they are fixed, means whatever, it does not depend on scale. Definitely that freezing point of water in Celsius scale, it is 0 degrees Celsius, and boiling point water in Celsius scale is 100 degrees Celsius. In Fahrenheit scale, is 32 degree Fahrenheit, right? And it is 212 degree Fahrenheit, boiling point of water I'm talking about. And in Kelvin scale, it is 0 Kelvin, it is 273 Kelvin, and it is 373 Kelvin. Point something is there approximately. I can say 273 and 373 Kelvin, right? Look, so all the scales have a lower limit and a higher limit. Of lower limit, not lower limit, I can say that this lower limit of the scale is actually corresponding to the freezing point of the water, and higher limit is corresponding to the boiling point of the water. And in between this interval, now how much the graduation is. Suppose Celsius scale graduates this interval in 100 terms, right? 100 graduations are there, 100 sections, 100 divisions. So each division is 1 degree Celsius, right? So there are 100 divisions. And Fahrenheit scale divides this in also 180 divisions, because these are linear scales. So the divisions are simply the boiling point temperature minus freezing point temperature. Here also boiling point minus freezing point, linear scale, right? It is a unitary method, right? So this boiling point temperature minus
0.15.
this, yes,
Freezing point by, yes, that is the
division. And this is also how many divisions are there in Kelvin scale then?
100.
Also 100 divisions, right? Now, in order to interconvert between the scales, you can always say that what is the 100 division in Celsius, it is the same 180 division in Fahrenheit, and it is 100 division in Kelvin,
True, sir. True.
right? Because whatever is the change in this freezing point and boiling point will remain the same for all the three scales. So the change in freezing point to boiling point is 100 division for Celsius scale, 100 division
Number of divisions.
in,
So the
in
deviation is
yes, linear divisions is equal to 180 divisions in Fahrenheit scale, and that is equal to 100 divisions in Kelvin scale. Yes or no? So I can say that
Yes.
one division in Celsius scale and one division in Kelvin scales, they actually refer to same change in temperature.
Linear everywhere, so
Yes.
same size. Yes, sir.
Same change in temperatures, right? So 1 degree Celsius and 1 Kelvin change is the same, but 1 degree Celsius change and 1 Fahrenheit changes are not same. Yes or no? Because 1 division in C is actually equal to 9 by 5 divisions in K in F. Yes or no?
So one division in C.
Is equal to 180 by 100 division in F.
Yes, sir.
Yes, sir.
So it is 9 by 5 divisions in F. So now if I
Yes.
want to convert C degree Celsius in degree Fahrenheit, right? X degree Fahrenheit. So what is X in
X.
terms of C? Look, C degree Celsius means how many divisions in C?
So it is C minus 0.
Yes, C divisions.
Yes, sir. C.
C divisions in Celsius scale.
Yes, sir.
So C divisions in Celsius scale, that means equal to C into 9 by 5 divisions in Fahrenheit scale.
C. Yes, sir.
C into 9 by 5 division in Fahrenheit scale. So now Fahrenheit scale starts from 32, and if I say I will move 9C by 5 divisions away from 32, then what will be my reading in Fahrenheit?
32 plus 9C by 5.
Reading is equal to 32 plus 9C by 5. So that is equal to degree Fahrenheit. C degree Celsius means equal to 32 plus 9C by 5 degree Fahrenheit.
Please wait.
Yes, sir.
So means from that 1 division is equal to 9 by 5 from there.
Yes.
Okay, sir. C.
Right? So this conversion is also important. Sometimes JEE Mains they have asked a few questions. Let us convert suppose 62 degree Fahrenheit in Kelvin. Can you tell me what will be your answer?
Yes, sir. It will be. It will be 276.33.
Yes, 62 degree Fahrenheit means how many divisions in Fahrenheit? 30 divisions in Fahrenheit.
30 divisions in Fahrenheit. Yes, sir.
30 divisions in
5
Fahrenheit.
degrees Celsius.
Yes.
Yes, sir, I am getting 16.5 degrees Celsius.
Not Celsius. I have to convert in Kelvin.
Yes, 5 Celsius.
30 divisions in Fahrenheit. 30 divisions in Fahrenheit is 30 into 100 by 180 divisions in Kelvin. Yes or no?
Divisions in Kelvin. Yes, sir. 30 into. Yes, sir. 5 by 9.
Sir, why you have taken 30?
30 divisions in Fahrenheit because it's 62 degree Fahrenheit. So if it is 62 degree Fahrenheit, then how many divisions are there? 62 minus 32,
Oh, okay, sir.
right? So that is equal to 100 by 6, 100 by 6 Kelvin. Then what is the reading in Kelvin scale? If the division is 100 by 16 Kelvin, then it should be 273 plus that much division.
Yes,
Yes
sir.
or no? So that is equal to 16.6, right? So 9
16,
9.5.
289.6 Kelvin.
6, 7.
Yes.
No.
Have you got it?
Yes, sir.
Yes, sir.
Yes, sir.
This was our JEE mains question. A linear temperature scale alpha is made such that freezing point of water is minus 60 degree alpha and boiling point is 150 degree alpha. Express the temperature of 120 degree alpha in Kelvin scale.
Okay, sir. So please wait.
Yes.
Please.
Look, can I say 210 divisions in alpha is equal to 100 divisions in Kelvin?
Yes, sir.
Yes, sir. Sir, is the answer 85.7? Oh, sorry, sir. Sorry.
Sir, is the answer 358.71?
Yes, yes, yes.
58.75.
Yes. So how many divisions are there in 120 degree alpha? It is 180.
180.
So 180 divisions in alpha is equal to
180 or 120?
120 minus of minus 60, na?
Yes, sir, 180.
Yes, sir.
So 10 by 21 into 180 divisions in Kelvin.
10 by 21 into 180 divisions in
600 by 7.
Right? So 3 দিয়ে যদি কাটি তাহলে এটা হয়ে যাচ্ছে
600
60.
by 7.
600 by
85.71. 85.71.
yes. So the reading in Kelvin is equal to 273 plus this one
600 by 7.
600 by
80.
7. 600 by 7 is how much?
So 85.71.
85.71.
Yes, 85.7. So it is 358.71.
58.71.
71.
Kelvin. Yes.
So give 71.
Yes, 71 Kelvin.
Yes.
Please wait.
Okay.
Yes, sir.
Yes, sir.
All right. Next, we will talk about thermal expansion. Thermal expansion is a phenomenon that is very commonly known phenomenon that if you heat some object and its temperature is increasing, then you will find that the shape, size or volume of the object is changing. For example, if you take a rod, a simple rod, and its length is L naught, if you increase its temperature by delta T, then after some time you will find that the length has increased from L naught to L naught plus delta L. Yes or no?
Yes,
And
sir.
this change in the length is given by this formula. This change in the length directly proportional to the initial length and the temperature change. So the constant of proportional, if it is alpha, then change in length is equal to L naught alpha into delta theta. Delta theta is the change in temperature. right? Instead of delta t, you can assume it to be delta theta.
Sir, why is it so that it is proportional to the initial length of that material?
Actually, what happens that if you increase the temperature, then the bonds between two molecules actually increases. So if the more number of bonds are there, then the greater will be the elongation,
Yes, sir. Yes, sir.
right? So that is why it depends on the initial shape or size also.
Yes, sir.
That means that initial bond length it depends.
Yes. Here alpha is known as the coefficient of linear expansion. Coefficient of linear expansion, right? Its unit is simply per degree Celsius. Because delta L and L naught has the same unit, so it will be per degree Celsius or per Kelvin, something like that. Similarly is the superficial or aerial expansion. Suppose this is a square plate, side length L naught are given, right? And if I heat it, temperature delta theta, then each length is increased to L naught into 1 plus alpha L naught into 1 plus alpha delta theta. Yes or
Yes,
no?
sir.
Yes, sir.
So if
So
I
will we
try
draw
to
this?
find, yes,
We'll draw this.
you can do it, yes. I'll send that PDF anyway. So L square, now the square plate has an area L square, which is L naught into 1 plus alpha into delta theta whole square. Yes or no? Now if I expand this term, then you will find it is L naught square into 1 plus 2 alpha delta theta plus alpha delta theta whole square. Yes or no?
Yes, sir.
Please wait, sir. So please.
But
do ask
alpha
the
value is very small in order 10 power minus 12. If alpha is very small, delta theta is also not that much large. So what is alpha delta theta square? Can I neglect it?
It will be 0.
Neglect it. So if I neglect it, then the term is 2 alpha delta theta. So if I say it is a naught into 1 plus beta delta theta, then what is the value of beta? Is the beta nothing but 2 alpha then?
Yes, sir.
Right? This is beta.
Hmm.
Similarly, if you have
Yes,
a
you were calling it
volume,
beta.
yes,
You were calling it beta.
yes. So what is beta?
2 alpha.
Beta is coefficient of superficial expansion. Superficial or surface expansion.
Aerial.
Aerial expansion. Similarly, if I say one volume is V naught and I increase the temperature, then volume becomes V naught into 1 plus gamma delta theta. Then you can say that I can also write that V volume is actually L naught cube into 1 plus alpha delta theta whole cube.
Yes, sir.
Approximately you can also make it L naught cube into 1 plus 3 alpha delta theta.
Yes, sir.
Other terms are
Yes.
negligible,
Mm-hmm.
right? So can I say that 3 alpha is nothing but gamma here?
Yes, sir.
Gamma.
So gamma is known as the coefficient of volumetric expansion or volume expansion.
So please wait, sir. So please wait. So the superficial we can call surface expansion also. Too.
Yes, yes.
Okay, sir. Done.
Now here we have assumed
So please wait.
one thing during all these calculations that
The cube.
here
Symmetric.
if this is L naught, this is L naught, and here if I say this is L naught 1 plus alpha delta theta, I have assumed the coefficient of linear expansion is same in this direction also, right?
Is it direction dependent?
Yes, sometimes, not in all materials. In few materials like graphite is one example where the coefficient of linear expansions are not same in all the directions, right? So we will, if nothing is mentioned, we will always assume a isotropic material. Isotropic means the alpha remains same in every direction.
So, means coefficient of linear expansion varies in graphite.
Yes, in different directions.
So why is it so?
It is because of the structure of the molecule and in different directions.
It's a planar hexagonal structure.
Yes, so it depends in its internal molecular structure, right? Such that it different in
If
different
nothing is-
directions. Or
if
the
nothing
bond
is-
property, you can say also in different directions the property of the bonds are different. If nothing is
Yes, sir.
mentioned, we will take materials to be isotropic, means alpha is same in all directions. In all directions.
Alpha is same. Yes, sir.
Right? Okay. Few examples are there. One such application of thermal expansion is in bimetallic strip. Right? In bimetallic strip,
Can you please once show the previous screen and the writing of the note once?
yes.
Yes, sir, done. Sir, done.
So there are some materials, there are some devices where you will find that as temperature increases or decreases, the circuit means makes or break automatically, right?
Yes, sir.
Suppose in electrical heater or iron or
Electric bell.
uh, in
Electric
refrigerators
bell.
also. Not in electrical bell. In electrical bell there is no heat generated. It depends on the heating property. So what happens actually, if you see that there are two metals, they are connected together like this, and they will have two different coefficient of linear expansion. So if this is a switch connected with this switch, you can see that in normal temperature this switch is connected, but as I increase the temperature, this alpha, suppose it is more than this one, alpha 1 is more than alpha 2, then what will happen, in this length will increase more than this one. If this length increases more than this one, but they are not connected together, right? So only way is that they will bend in this way, such that this this material which having more coefficient of linear expansion will be outside of the bend, so that it has a larger length than this one. Yes,
So
sir?
means the one
Sir,
which
these
should
things are used in fuse.
or be that outside.
Yes, that can be used in fuse also, uh, but it is not used in fuse. Normal fuse, this is not used. Here you can say this is one type of circuit
Right.
breaker like thing, right? As
So
the
where do we use this? Can you repeat once?
why?
Where do we use this?
We can use it in any circuit where the temperature dependent devices are used. Suppose in not heater, you can say iron. Have you
Yes,
seen
sir.
iron while
Sir, fire alarm.
yes,
Sir, fire alarm.
which alarm?
Sir, fire alarm.
Fire alarm, yes, definitely. You can say in fire alarm, right? In electrical irons
That
or
is
in
the electric bell,
refrigerators.
sir, fire alarm.
Yes, yes, fire alarm. A bell is just something different, but fire alarm, yes,
Switching on a bell applies that, not working of the bell.
yes. So this type of situations are there in bimetallic strip. Okay. Now one example is that if there is a cavity inside a square plate and if I increase the temperature, then what do you think? What will be the radius R will be and what will be the length A or B? Will A B increase, R decrease, or R increase, A B decrease, both will increase, both will decrease? What will happen?
Everything will increase.
Both everything
Everything will increase. Yes, that you need to understand that this expansion is one type of photographic enlargement. What do I mean by photographic enlargement? If you have a
Yes, sir.
photo, passport size photo, and if you just make enlarge this photo,
Zoom.
right, you will find that it is not that your photo will remain same and everything else will only increase.
Yes.
Right, you will see that everything will increase proportionately, right? So distance between two eyes, now it has also increased. So in a similar way, here if you see that the thermal expansion is photographic enlargement, that means if you take 2 points here and here, after temperature rise, you will find that these 2 points will also increase in length, right? So basically, the distance between any 2 points will increase.
Sir,
Distance between, bolo,
hello, sir.
bolo.
So if there is a sheet with a hole, means a considerable amount of a circular hole with considerable radius, then
Hmm.
if we increase, then the hole will also increase.
Yes, yes. So any 2 points will increase in the material. These 2 points are inside the material only. So it doesn't matter what is in between them. In between them, there is a gap, or in between them, there is material. If you increase the temperature, then these 2 points will all, the line joining
The two
between these two
points
points
should
will
be in
always line.
the material. Two
Yes,
points
the
should
point
be in the
should be,
material.
yes, definitely. Otherwise, you cannot say I will take these 2 points in air and they will also increase. That is not happening, right? The point should be inside the material, right? And that will always increase like this. First, do this question. A metal rod A of length L naught expands by delta L when its temperature is raised by 100 degrees Celsius. Another rod B of different metal of length 2L naught expands by delta L by 2 when the same temperature rise. Third rod C of length L 3L naught is made with A and B, right, and it expands by 2 delta L on hitting 100 degrees Celsius, or 100 Kelvin is the same thing. The length of each portion of the composite rod is.
Okay, sir. So please wait.
This is rod A and this is rod B. Its initial length is L naught and its initial length is 2L naught. By changing temperature by delta theta, its length has changed by delta L, L naught plus delta L, and this has changed delta L by 2 by rising the same temperature delta theta, right? Now suppose this is some other color event. Now I have made a rod C by combining A and B. Right? A is up to this length and B is up to this length. So if I say here the length of A is L and B will be 3L naught minus L. Right? So if I increase the temperature by delta theta, the net increment is 2 delta L. Right? 3L to 3L naught plus 2 delta L. This figure is given. Informations are given. So what I can write here, that delta L is equal to L naught alpha delta theta, alpha of A, delta L by 2 is equal to 2L naught alpha of B into delta theta. Yes or no?
Yes,
So
sir.
here 2 delta L is equal to L alpha A delta theta plus 3L naught minus L alpha B delta theta. Yes or no?
Yes, sir.
So I can say what is alpha A into delta theta by delta L by L naught?
Alpha A into delta theta is delta L by, yes, sir.
What is alpha B into delta theta?
Delta L divided by 4 L naught.
So from this equation delta L gets cancelled out. Can I say 2L naught is equal to L plus 3L naught by 4 minus L by 4?
Yes, sir.
So 5L naught by 4, if I take it here, is equal to 3L by 4.
5 L naught by 4.
Yes.
Yes,
So L is equal to 5L naught by 3.
yes, sir.
Right? And another will be 4L naught by 3. So option A is correct answer.
So please go.
This question says a meter washer has a hole of diameter D1 and external diameter D2, where D2 is equal to 3D1. On heating, D2 increases by 0.3%. So percentage increase in D2 is 0.3. What will be the percentage increase in D1? I can use this equation D2 equal to 3D1, D2 equal to 3D1, and as I have seen that D2 increases by 0.3%, so delta D2 is equal to 3 delta D1, right? Now it says that percentage increase is 0.3, so delta D2 by D2 is equal to 0.3. It is given in your question. I have to calculate what is delta D1 by D1. Now delta D1 by D1 is equal to delta D2 divided by 3D1. Now 3D1 is also D2. So it is nothing but delta D2 by D2. So the percentage change will be the same. 0.3% will be this one also. Right? And definitely it will increase, as I have told you that on heating, in the distance between any 2 points will increase, just like a photographic enlargement. Right? So this will be your answer of this question. This question says a steel scale measures the length of a copper rod as L0 when both are 20 degrees Celsius. Which is the calibration temperature of the scale also? the scale reading when both are at 40 degrees Celsius is. Now here,
So will the alpha be needed?
yes, the alpha will be given definitely. Alpha of steel and alpha of copper is given.
So
Right?
may I try?
Yes, tell me what's your answer.
The L naught minus 20 L naught into alpha S minus alpha C.
No. Look, the answer will be something like this. This was the initially, suppose, copper rod, right? So this is the copper rod whose length is L naught and it is measured by steel rod, right? Suppose this is the steel rod, steel scale. So this is the steel scale, right? So while measuring this with this steel scale, actually you have measured this L naught divisions, right? This is the steel and this is copper. If I increase the temperature, then the length of copper will become L naught into 1 plus 20 alpha copper. Yes or no?
Yes, sir.
Now, if I want to measure the same copper rod by a steel scale, now is the scale remain the same or scale has also increased its size?
So increased.
Increased.
So can I say that each unit of the scale, each division of the scale, which was earlier 1 unit, now this 1 unit length was not 1, but the 1 unit length is increased to 1 into 1 plus 20 alpha steel.
Yes, sir.
So now if I ask you that how many divisions are there? How many
This is the
divisions?
new 1 unit.
Yes, this is the new 1 unit. So how many divisions are there? You are going to divide this with
Divide
this
with-
one.
Yes, sir.
So 1 plus 20 alpha copper divided by 1 plus 20 alpha steel. That should be your answer.
Sir, please wait.
Please divide that. That means that way.
Because whenever
Sir,
we
it's
have
not
to,
measure.
yes, whenever we have to measure something, we measure it by its divisions, right? Suppose you are measuring 15 centimeter of a rod. Then how you measure it? You take a scale and you count that how many divisions are there in that scale. Yes or no?
Yes, sir.
Now, if you have a 15 centimeter rod and suppose you take a scale where each division is 1 centimeter, so you will say that the reading is 15 centimeter. But if you take up a scale where each division is 1.5 centimeter long, then if I ask you what is the length of the
10
rod,
units.
what you will
10
say?
units.
10 units. How you have got it? You have just divide that 15 divided by 1.5 now.
Okay, sir.
Yes, sir. Got it, sir.
This was a different sort of question.
Yes. So you have to understand how do we measure in a scale. All right. Is it okay to all?
Yes, sir.
Yes, sir.
Sir, can you please one show the writing?
So this delta theta is always in means centigrade. So
Yes. The change is always in degree Celsius or degree Kelvin. Both are the same.
same change.
Yes.
Sir, when we will get our results?
You haven't
Yes,
got it
sir.
yet?
No, sir.
No, sir.
Okay. I think it will take some time because they are sending results one by one, batch wise.
So
So-
this page is done.
Okay. So you'll get it. No problem. We'll get it soon. So this is done. Now come to the next question. It says an isosceles triangle is formed by two similar rods AB and AC, each of length L1 and coefficient of linear expansions alpha 1.
Not done.
Have I given this as your homework?
No,
No, sir.
No. Okay, you try it now. Another rod of length L2 and coefficient of linear expansion alpha 2. So you can see that in this triangle, two rods AB and AC are of similar nature and the base BC having a different expansion coefficient alpha 2. You need to calculate the ratio L1 by L2 so that the height from A to the BC is always same in all temperature. All temperature means you are not changing a huge temperature, but a small temperature change will not affect the height from A to BC.
Sir, may I try?
Yes, okay. Tell me the answer.
So 1 by 2 into root over alpha 2 divided by alpha 1.
Yes. But the question says that this height will never change, it will remain the same. So if I try to write down this height h in terms of L1 and L2 at any instant,
L1 square minus L2 square by 4.
yes, h square is equal to L1 square minus L2 square by 4. If I differentiate it, 2h into dh is equal to 2L1 dL1 minus 2L2 dL2 by 4, right? And as you can see that dh should be 0 because the change is 0, right? So 0 should be L1 dL1 minus L2 dL2 by 4. So L1 by L2 is equal to 1 by 4 dL2 by dL1. Now dL2 is L2 alpha 2 and dL1 is L1 alpha 1. So if I take L1 L2 again here, that L1 by L2 whole square you will get as alpha 2 by 4 alpha 1. So L1 by L2 is root under alpha 2 by 4 alpha 1. That should be
1 by 2 times.
Yes, 4 is in inside bracket. You take it outside, so 1 by 2 times.
Yes, sir, done. Your style was really nice.
Yes, have you got this one? Look,
Yes,
small change in temperature means you can always differentiate this.
Small changes.
Yes, sir.
The volume of the glass bulb of a glass barometer is V naught and area of cross section is A naught. Area of cross section of the tube at 0 degrees Celsius, mercury just fills that bulb. What will be the length of the mercury column at T degrees Celsius? Alpha glass and gamma mercury both are given. Right, a glass barometer. I think you have understood how glass barometer looks like. There is a bulb and there is a tube like this. Great. Yes.
Sir,
Bolo.
sir, can you please explain this question again?
The question says that at 0 degree Celsius, mercury fills this bulb completely. At T degree Celsius, what will be the height of the mercury column inside the tube? Cross section area of the tube is A0, volume of the bulb is V0, and the
That V0 and A0 are at 0 degree.
at 0 degree only. Alpha glass and alpha gamma of mercury is given.
We'll find the measure that. Oh, okay, sir.
That height
So
of
please
the
wait.
liquid. Look, if the initial volume of the bulb is V0 and mercury is V0, after temperature rise, glass and mercury, they will expand differently, right?
Yes, sir.
So what is the volume of the glass? Volume of the glass will be V0 into 1 plus 3 alpha glass into T. Yes or no?
Yes, sir.
And V of mercury, volume of mercury will be V0 into 1 plus gamma T.
Volume of mercury.
Volume of mercury will become this one.
Yes, sir.
Yes, sir.
So what is the change in volume? Extra volume, what will be the extra volume the mercury has? Mercury will be definitely, mercury volume will
More.
rise more.
Gamma will be more.
Yes. So V0 into gamma minus 3 alpha into T.
Yes, sir.
Sir, V0 into
Gamma minus 3 alpha. If you subtract it.
Gamma and alpha.
Now this extra volume will only rise inside the tube.
Yes, sir.
but the area is A0.
Area will also change.
Hmm.
Area will also change.
Yes, sir.
Yes, sir. I forgot that.
Divided by area is A0 into
1 plus
1 plus 2 alpha glass into T. Yes or no?
So please wait a bit.
Yes, sir.
The last part, what you did, can you please say?
Sir, last তে T common তো হবে না?
A0 into acha T by it. Okay, yes. This one will be T.
Yes, sir.
So last step, you please say once.
This volume is inside the tube. So if the area cross section is A, then height into area is that volume.
And area
So
will
height
also
is
increase.
equal to this volume divided by area. Area has increased. Now area is become this one.
So, but it should be area of the glass, no, not area of that. Means it is hollow, no?
Yes, hollow will also increase in the similar way.
Okay, sir.
This question says left arm of the U tube is immersed in 0 degree Celsius hot water and right arm is in melting ice. The left arm is in hot water T degree Celsius and this one is melting ice at 0 degree Celsius. Right arm. Height in the manometric liquid is HT and H0. What is the coefficient of expansion of the liquid?
Okay, sir.
Melting ice means 0 degree Celsius.
Sir, we will not take the expansion of that manometer.
No.
Sir?
Sir, will the answer be HT minus H0 divided by del T into H0?
Let me check.
Sir, may I try?
Yes.
Yes, sir. It will be HT minus H0 divided by TH0.
Yes, sir. This is what. Yeah.
Alright. Can I write this equation as in equilibrium rho T degree Celsius G into HT is equal to rho at 0 degree Celsius G into H naught.
Yes, sir.
Now I know that density into volume is a constant,
Yes, sir.
right?
Density into volume.
Is mass.
Mass of the whole system.
Yes, of any particular system if you take. So d rho into V plus rho into dV equal to 0.
Yes, sir.
Yes,
So
sir.
d rho is equal to minus of rho into dV by V,
Yes, sir.
Yes, sir.
Yes, sir.
right? Now dV by V is equal to what? dV by V
Gamma
is
T.
equal to gamma T,
Gamma T.
Yes, sir.
Yes, sir.
right?
Yes,
So
sir. Yes, sir.
delta rho is equal to minus rho gamma del into T or delta T.
So delta rho.
D rho and delta rho, they are same, small
Yes,
change
sir.
in density,
Okay, got it.
right? So actually density after time t will become less than what was at 0 degree Celsius
1 month.
by 1 minus gamma delta T.
Yes, sir.
1 minus. Oh wow.
Right?
So this relation we have to remember.
You can remember it. Right?
So means for density also, if we change the density temperature, then it varies
Yes.
as the volume.
It will vary as that of volume.
It will decrease. Yes.
Now we can say that from this first equation and the second equation, we can say that Ht into 1 minus gamma delta t is t here, that should be is equal to h naught. Yes or no?
Yes, sir.
So gamma is equal to 1 minus h naught divided by ht divided by t.
Gamma is equal to by
This
T.
one?
Yes, sir.
Yes. So this
Okay,
is
sir.
ht minus h naught divided by tht. Okay, all right. Okay, now let us come to this clock problem. This is one type of application you can say of thermal expansion.
We try.
Okay, let me first give you a idea of what is this question. This question says about the time period, right? So let us just try to understand this, that how temperature affects time period. Affects time period. If you have seen any clock, clock, or seconds pendulum, it says, right? Pendulum clock. How does pendulum clock measure time? It also says a seconds pendulum. Seconds
Can you please
pendulum.
repeat this part, sir?
Time period is 1 second.
Yes, I'm saying that there is a clock which is known as pendulum clock or seconds pendulum. The clock measures time by this way, that there is a pendulum, right? And that pendulum
Yes, sir.
moves to and fro, right? So the pendulum moves away from it comes here, and again comes back here, goes at this extreme, and again it comes back from this extreme to this point. So this constitutes a complete time period,
Yes, sir.
right? Can you understand what is a complete time period? It starts
Yes, sir.
from here.
Second.
It starts from here, goes to this extreme, and again comes back to this extreme, and comes back to this position again. So this
That
From the
total
mean
is a-
position to the extremes and then back to
then
the mean
back to the
position.
mean position, right? This total time period is 2 seconds. This total time period is how much? Oh, 1 second.
Sir, is it again
I can
not working?
explain, yes.
Sir, it's terrible again.
Thank you. Yes, sir.
Sometimes it shows this problem. Don't know why. 1 second. I think the port is problematic. Okay, let me try. So here, this total time period is 2 seconds, right? So a clock does not know what is 2 seconds. A clock only uh, mm, reads a 2 second when pendulum again comes back to this original position. Right, now try to understand one simple thing, that suppose in originally, if this pendulum takes 2 seconds exactly to come back here at the same position, the clock will show you the correct time. Right, now suppose a pendulum takes not 2 seconds, 1.5 second to come back to the same position. What will you say? Will the clock show the correct reading, or it will be a fast clock, or it will be a slow clock?
It will be a fast clock.
Fast.
It will be a fast clock.
Fast clock. Why? Because the clock will give you 2 seconds after every
The
1.5
1
seconds.
second is completing in 2 seconds is
If in less
completing
than
in
2 seconds,
1.5
it is showing it has completed 2 seconds.
Yes. So in
Yes,
1.5
sir.
second only, suppose it takes 1.5 second. So you will see that after 1.5 second, it is showing you 2 seconds. Right? So if time period is less than 2 seconds, the clock is fast. The clock is fast. And if time period is greater than 2 seconds, the clock is slow. Right? How the time period can change with temperature? There is a formula you should remember. We will do it in SHM chapter. Time period formula is 2 pi under root of L by G. Right? You have to remember this formula. We will not derive this right now because we will do it in SHM chapter. If the length of the pendulum clock is L, then the time period is 2 pi under root L by G. Right? So if I increase the temperature, then this length will increase or not?
Yes, sir, it will increase.
If I increase the temperature, then time period will also increase.
Yes, sir.
If time
Yes,
period
sir.
increases, then it will make
It will
the
become a
clock
slow clock.
slow. Right? It will make the clock slow. So how much it will make the clock slow, or how much it will make the clock fast, that also we can calculate. How do we calculate that? If t equal to this one, then you can say that delta t is equal to 2 pi by root over g. Root over L power half means
Slow.
1 by 2 root L.
Half times L to yes. Delta L.
Right? So what is delta
Yes.
t by t?
2 to cancel.
Delta t by t. What is delta t by t? It is 1 by 2 delta L by L. Can you divide this delta T with this T? 2
Yes,
pi by
sir.
So
root
1 by 2 delta L by L.
1 by 2 delta L by L, yes.
Yes, sir.
Right? Now I know what is delta L. What is delta L? Is it L alpha delta theta?
Yes, sir.
So what did you do, sir?
Yes, I have just replaced delta L by L alpha delta theta. So it is alpha into delta theta by 2.
Yes, sir.
Yes. So delta T by T is the percentage change of the time period. Yes or no? Or
Yes, sir.
Percentage of fractional.
fractional change in the time period. If you multiply it with 100, you will find the percentage. So delta T by T is equal to percentage change in time period. So if the original
So
time,
how did you get half into delta L by L, that part?
can you divide this with this one, delta T by T? This divided by this one.
2 pi will get cancelled.
Root G will get cancelled. So only root L and root L will be L.
Root L will multiplied. Huh?
Yes. Have you got it? So if I say that in one day, in one full day, how much is the time change? How much is the time change? How do I find that?
Sir, can you please repeat what did you say?
I'm saying this delta T by T is this one. From this data, can you tell me in one full day how much will be the gain or loss of the time for that watch? Can I say from this,
Well, just put in place of t number of seconds and then look at lag of seconds from delta t.
can I say that in 2 second, delta T is equal to alpha into delta theta if T equal to 2 second?
Yes, sir.
Yes, sir. If so, sir, capital T is time period or after how much time we are calculating?
No, here capital
Time
T is
period.
time period only. This time period is 2 second.
Yes, sir. Means we are considering it as the seconds pendulum.
Yes. So can I say in each 2 second, in every 2 second,
There will be a
the
change of
change
the
is
alpha delta.
delta theta? In every 2 seconds,
Yes,
the
sir.
change is alpha delta theta,
Yes, sir.
right? So in every 2 second, if the change is alpha delta theta, then what is the total second in a day that I can calculate in that way?
86400.
6, 4.
Can I say in every 2 second change is alpha delta theta? So in how much is the second in a day? What is the second in a day?
86400.
86400. Okay. So in this much second, how much is the change? That you can calculate alpha delta theta by 2 into 86400 second,
Yes, sir.
Yes, sir.
right? So that much will be gain or loss in a particular day on that watch.
Sir, please wait.
This question says a clock with metallic pendulum gains 6 seconds each day when temperature is 20 degree and loses 6 seconds each day when temperature is 40 degrees Celsius. What is the coefficient of linear expansion of this metal? Option A, only power is the change, right? The value is the same.
No, sir, D value is different.
D value is different, yes. All the other values is 1.4. Suppose, let us assume clock correct reading or correct time at T degrees Celsius. So when it is less than T degrees Celsius, the gain, when it is less than T degrees Celsius, it is slow, right?
It is
Fast,
fast.
sorry, fast.
Fast.
So it gains alpha into delta theta divided by 2. Delta theta means, here you can say delta theta means T minus 20
T minus
Yes,
20.
sir.
into 86400. That is equal to 6 seconds.
So means in gain or loss we have the same formula.
Yes. Right?
We have
Or
to just
loss
adjust that.
is alpha into 40 minus T by 2 into 86400 is equal to 6 also. So from there I can
Yes.
say T is equal to 30.
Yes, sir.
Yes, sir.
If T equal to 30, so 5 into alpha into this equal to 6. So alpha is equal to 6 divided by 5 into 86400. Right? So if I say what is the power only, then I can easily find what is power.
6 by 5 is 1.2.
So yes, it is 1 point something, 6 by 5, 1.2, and it is 1 divided by near about 1, 2, 3, 4, 5, 10 power minus 5 order will be there. Yes, so that option A will be correct definitely. Right?
So should we means use that like you means that will it always be correct?
Which one? If I
Yes, that divided by 86400 I chose it to be 10 to the power 5.
no, I have roughly done that because only the options are varying in powers. So that is why I could do it. Otherwise, the number, if numerical value is also different, I had to do it more calculation.
So please wait.
Okay. Now we will talk about thermal stress, right? This is another concept, concept that we have already studied in properties of material. We'll apply here the same concept, thermal stress. Thermal stress. So what is thermal stress? Do you remember what is stress? Stress is developed when there is a force or pressure, normal or shear on any surface, right? So let
Yes,
us
sir.
assume one thing, that suppose there is a rod and the rod is fixed between two fixed supports. This is one support and this is another support. The rod is fixed in between these two supports. Length is alpha, its length is L, expansion coefficient is alpha, and Young's modulus is Y. Cross section area is also A given. Suppose the rod is at 0 degrees Celsius. Now if I increase the temperature of the rod by theta degrees Celsius, so delta theta, I have increased the temperature. What should happen? If you see that in one way the rod should increase its length, another way, as these two supports are fixed, it cannot increase its length. Yes or no?
Yes, sir. So it
Yes.
will
It should increase its volume also, no?
area.
Yes. No, it's not volume, because volume change only happens when the forces are from all the directions.
That the rod will bend.
Sir,
The rod can bend.
It has finite volume. Why will it not change? The area will increase. Not like that.
No, these are fixed. Area cannot change. These are fixed means this area is also changed. Also fixed.
Okay.
All
Yes, sir.
area is also fixed.
It should break then.
There is one thing, yes, it can break, but that has a limit that it will not bend always. If you change the temperatures for a small value, it will not break or it will not bend, right?
Hmm.
And so what it will do actually, if you see, if one end was free to move, if one end were free to move, then this rod would have increased its length like this, yes or no?
Yes, sir. Yes.
Yes, sir.
Yes,
If it
sir.
were free to move, then this rod would have bent, increased its length. Now, as the rod is not free to move, can I say that this wall is actually pushing this rod with a force such that it has changed its length from here to here?
So please wait.
Sir, please repeat this
What
part.
I'm saying that if suppose this wall is not there, so the rod would have moved from here to here. Now, in order to make this rod again in the same length, what you are doing, you are pushing this rod from this side with a force F,
Yes, sir.
Yes, sir.
right? And during that force, actually you are changing the length of the rod by this same amount,
Yes, sir.
Yes,
L
you can
alpha
think
delta
like
theta. Yes or
Means
no?
we're thinking it like that.
Yes. So actually there is a stress developed inside the rod because of this force.
yes.
The rod cannot
Yes.
expand. More you increase the temperature, more it tries to expand. So the internal force will be more. And in order to balance that internal force, the external force offered by that wall will also be more.
Yes,
Yes,
it will
sir.
increase.
Yes.
It is in equilibrium, no?
Yeah, always it is in equilibrium.
Forces.
So what can I say about that stress? Can I say there is a stress developed inside the rod due to this
Yes, sir.
temperature rise?
Yes, sir.
And that stress equal to F divided
by
by A, right? And what is the strain?
Strain is L alpha delta theta divided by L. Matlab, means alpha delta theta.
L alpha delta theta divided by L, right? Although you can say that here the natural length is not L, the natural length is L plus L alpha delta theta. But in comparison to L alpha L, the alpha delta theta or L alpha delta theta is very negligible.
So
So you
that
can,
part can you please explain? Means that opposite force is being applied. How
Sir,
the
why
stress
you have
and strain
taken
is developed?
it here as strain? It changes its length.
it is not changing its length. Yes, it is not changing its length. But what is the original shape here? The original shape of the rod is like this. The original shape, if you can say, that in normal condition, the length of the shape of the rod should be like this. After that, when I apply this compressive force, then I am decreasing the length of the rod from this to L alpha delta theta.
Okay, okay.
Yes. Now you can
Okay.
apply the
Yes.
stress by strain formula, which is equal to Y.
Sir, can you please wait once?
Yes. Stress by strain is equal to Young's modulus. So if you do not know what is the elongation, what is the force, or if you know what is the force, what is the elongation, you can apply this formula in order to calculate all these things.
Sir, will we remember the formula or just apply through the equations?
This formula already we have discussed. So which formula you have to remember? Nothing.
No, that in terms of alpha delta theta. That
No,
all.
no, not needed. Not at all needed. You only have to understand that concept But you need to remember that first you let one end is free to move, right? Then you apply force and then you can understand it in better way.
Yes.
Have we got this one?
Yes, sir.
Now can you try to solve this question based on a very similar concept that we have just discussed? Just try to form the equations, then we'll check. Okay, look. This is the initial length. Of this rod L1.
So same problem.
Same problem. This is the initial length of the rod L1 and this is the length of the rod L2. It says that when the temperature is increased, two rods of different metals have same area placed between massive walls. L1 alpha 1 y1, L2 alpha 2 y2 are given. Temperature is raised by T degrees Celsius. Find the force with which the rod acts on each other and the length. Now, can I say that this junction will remain there? Yes?
The stresses will be equal in both the parts.
Yes, definitely. So it is not necessary that junction point will be here only. Right? So let us
Their
assume.
only strengths are equal.
Let
Sir,
us assume.
find the force with which the rods act on each other.
Yes, yes. So let us assume that this junction
It's a terrible problems.
yes, it is drawing by itself. Oh. Let us assume that this junction has shifted by x.
Yes.
Right? So if this junction has shifted by x, let us say that if this end were free to move, then this would have expanded by this length.
Yes, sir.
What is this length?
It
L1,
is
L1
1
into
to
alpha
L1
1 into T.
alpha 1t.
And if it were free to move, it would have expanded by this length.
L2 alpha 2 into T.
But they have not expanded till this much. So there is some external force acting on this rod in this direction, which has changed its length from here to this much. What is this much? This much is L alpha t minus x.
Yes, sir.
L1
Alpha
L1
1
alpha 1
t.
T minus x.
And the same
Yes.
force is acting on this surface also.
Yes, sir.
This force has changed the length by this much.
More. Yes,
L2
sir.
alpha 2 t plus x.
Right? So can
Yes,
I
sir.
say that the stress for this rod, for red color rod, the stress is F by A.
Yes, sir.
Yes.
That is equal to delta
Y
L
time.
L1 alpha 1 T minus X divided by L1
Times
into
Y.
Y1,
Yes, sir.
Yes, sir.
and for this white color rod,
Oh God.
for this white color rod, the same F by A is there.
Yes, sir.
That should be equal to L2
L2
alpha 2
T
into T
plus
plus
X
X divided by L2
L2 into Y2.
into Y2.
Yes,
Now, if
sir.
you equate this two, you will find what is the value of X,
Yes, sir.
right? And if you find what is the value of X, you can find what is the value of F. That is the first answer.
Yes, sir.
And the length of the rods will be L1 plus X and L2 minus X.
So please wait. L1 plus X.
The red color rod will be now L1 plus X, and white rod will be of L2 minus X.
Yeah, I thought that the rods will retain their original lengths.
No. If it
No, you said no. That when two are connected by a wall, then
yes, if one rod has two ends connected in between walls, definitely it will have the same length. But here this junction is free to move, no one is going to resist the motion of the junction.
where the force is there, F. Yes.
Yes, so that is why this junction will move, shift by X. Now this question says two steel rods and one aluminium rod, each of equal length and equal cross section, are joined rigidly at their ends. All the rods are in a state of zero tension at 0 degrees Celsius.
So zero tension means?
Means there is no stress developed.
Okay.
Find the length of the system when the temperature is raised by theta. Coefficient of expansion, aluminum steel are given, and Young's modulus are also given.
YA and YS. So
Yes, here these two ends are rigidly connected, but it is not fixed, right? These are rigidly
কোনটা
connected.
বেশি বাড়ে স্টিল না অ্যালুমিনিয়াম?
You can assume any one of them, right? I think aluminium will increase more, but you can assume anything. If it is not given, your answer will adjust itself.
ওকে
So?
স্যার।
Suppose this is the length L0, and in equilibrium its length has increased by X. Okay, in equilibrium its length has increased by X.
So by X.
Yes, by X. I have to calculate X. If it were free to move, then I can say that this length is L0 alpha steel into theta. Yes or no?
Yes, sir.
Yes, sir.
And this length is L0 alpha aluminium into theta.
Yes, sir.
Yes, sir.
But it has increased only up to this. So there must be some force which is applicable on this aluminium rod, which has decreased the length by this much.
Yes, sir. It will be that because of the steel rods.
Yes.
That means at first we have left it, then we are seeing how this much force is required
Yes.
to decrease the length by this much.
So that force has decreased its length to L0 alpha aluminium theta minus X.
Yes, sir.
Yes, sir.
And can I
yes.
say the same force will be applicable to the two steel
Steel.
rods? So it will
Yes,
be
sir.
F by 2 each.
So will the forces be
Yes, sir.
forward? That is my problem.
Yes. Net force should be 0. So if this force is in this direction, then the steel force on steel rod, the force will be in forward direction.
Yes, sir.
Net force on the system.
Yes. If this is the strip, the net force on the strip should be 0. As I've told you, it is always vertical. So this force is in this direction. So these two forces will be in forward direction. And due to this force, now the elongation of this is x minus this one.
Yes, sir.
So for the steel rod, can I write this equation? F by 2a is equal to L naught alpha steel theta x minus divided by L naught into y steel.
স্যার এখানে আপনি এক্সটাকে আগে কেন দিলেন?
The elongation is
direction.
x
Acha,
minus
yes,
this
sir.
one. And for aluminium rod, can I say F by A is equal to L naught alpha aluminium theta minus x divided by L naught into y aluminium.
Yes, sir.
Can you write this?
That means we have
Yes,
to
sir.
keep that strip vertical.
Always, yes. It is not bending. So now we can equate these two and we can find our answer for x.
Yes, sir.
Right?
Sir, I forgot to take that Young's modulus, and so my answer was without Young's modulus.
Yes. So 2ys by L naught gets cancelled out. So 2ys into x minus L naught alpha s theta is equal to ya into L naught alpha a theta minus x.
Yes, sir.
From there you will calculate the value of x.
Yes, sir. It will be.
Right? Solve the calculation x. Have you got anyone? The value of x? I think if I take x in this side, so 2ys plus ya will be there. And this will be L naught into alpha a.
Sir, it will be L naught into theta into alpha a
Ya,
into
alpha a.
plus 2 into alpha s into ys divided by 2ys plus ya.
Yes. Divided by 2ys plus
ya. Yes, sir.
Right? And the length will be L plus x. L naught plus x will be your answer.
Please wait.
This question says a composite bar has two segments of equal lengths L each. Both segments are made of the same material, but cross-section area of segment OB is twice that of OA. Bar is kept on a smooth floor and joint is at the origin. Temperature of the system is uniformly raised by delta theta. What is the x coordinate of the joint if the linear thermal expansion is alpha? So no hindrance is there, nothing is fixed, nothing is supported. It is only kept on a floor. So what is the concept behind solving this question? Can anyone tell me how to solve it?
The center of mass of the composite rod will be at rest.
Yes, center of mass will not move. as because there is no external force horizontally acting on it, right? So can you just try to solve it? Okay, let us try to understand what it is talking about. Two bars are there. One, suppose this one, another is this one. Lengths are same, cross section double, cross section area double, so volume is double, mass is double. One mass is m, another mass is m by 2, right? So this is the junction for y equal to 0 and x equal to 0 point, right? Take the same point, same reference line. Let us assume that the new junction has been shifted at this level by distance x. So the red color rod I can start drawing from here, and it has been elongated by some amount due to the temperature rise. And the white color rod, it is also there, it has been elongated by some amount due to the temperature rise. I have to find this shift. Let us assume it to be x. This mass is m, this is double the mass. Initial center of mass was here and here. Now the center of mass is located here. So this position I have to calculate from origin to this center of mass, right? This length has been now L naught into 1 plus alpha theta. This length is also L naught into 1 plus alpha theta. So this center of mass is x plus L naught into 1 plus alpha theta divided by 2, and this center of mass is L naught into 1 plus alpha theta by 2 minus of x, right? Because from here to here it is L naught by 2 1 plus alpha theta minus x. So now I can equate the center of mass positions. Initially the center of mass will be 2m into L naught by 2 minus m into L naught by 2 divided by 3m, and that is the same as final 2m into x plus L naught by 2 into 1 plus alpha theta minus m into L by 2 into 1 plus alpha theta minus x whole divided by 3m, right? 3m gets cancelled, mm gets cancelled. So I can say it is L naught by 2, that will be equal to 2x plus L naught, 2x plus L naught plus twice alpha delta theta, twice alpha theta minus L naught by 2 minus L naught by 2 minus L naught by 2 alpha theta and plus x, right? So L naught by 2 and L naught by 2 gets cancelled out. So I can say 3x is equal to minus 2 alpha theta plus L by 2 alpha theta. That means 2 minus 1 by 2 is 3 by 2. Is it correct? 2 minus 1 by 2, it's 3 by 2. 3 by 2 L naught alpha theta. Minus sign will be there. Yes or no? Yes. So I think the answer for x will be minus L naught alpha theta by 2. Have you all got the correct answer?